hi all, let's just solve this question which is based on linearly independent vectors. So what they are saying, find the number of linearly independent vectors in the following set S. So a set is given to us and then they are asking that number of linearly independent vectors. This question is taken from Washington University in St. Louis. So let's just see this question. So maybe I can copy this particular set, whatever is given there, on the next page and then I can show you. Okay. So what we can do, we can decompose this particular parametric form into a linear combination of some vectors, right? Which means this will be 1, 2, sorry. So here A will be 1. Let me just first tell you, here A will be 1. Everything else will be 0, which means B equal to 0, C equal to 0, right? Here B will be 1 and everything else will be 0. Here C will be 1 and everything else will be 0. I mean, this is just a shortcut that we apply. If you remember that we have already covered in our course. So there C will be 1 and everything else is 0. Now let me write the coefficients. So it will be 1 minus 0 plus 0, right? So it will be just 1, 2, minus 1 and 3. It will be 2, 5, 4 and 1. It will be 5, 8, minus 8, 7 and 1. So these are the 3 vectors we have got. Now in that set, we just talked about in that set. So here all the vectors will be a linear combination of these 3 vectors. Now we only need to check that whether we have these 3 vectors as linearly independent vectors or not. Which means out of these 3 vectors, we still have to check that how many vectors are linearly independent. See, we have already solved these kind of questions, and there what we do, like there generally we have something like this. Let's suppose this is the vector we have. Generally we get something like this. This is 1, 0, 0 plus B, and then this is 1, 0, 1. So generally we have something like this where we don't need to check linear dependency and independency. Why? Because here, I mean, this is something that we got from the system of linear equations, right? So if x2 and x3 are free variable, then you will be having just a and b. At one place you will be having a, at another place you will be having b. So automatically you will be having 1, 0 and 0, 1. Automatically it happens in case of system of linear equation. So you don't have to check whether these 2 vectors are linearly independent or not. These will be definitely linearly independent because of this particular thing. Because you have at one place a, at another place b, right? That's why in system of linear equation, automatically you get linear independent vectors. But here this 1, 0, 0, 1, this kind of pattern is not there, right? Anywhere this kind of pattern is not there. That's why you still have to check whether these 3 vectors are linearly independent or not, right? I mean, how many vectors out of here are basically linearly independent? So maybe we can check it quickly, right? And then we can decide whether we have these 3 vectors are linearly independent answer, or these or lesser vectors are linearly independent answer. So what we need to do, we basically have to put all of these vectors in one matrix, and then we have to check whether these 3 vectors are linearly independent or not. So let me just do it quickly. So you just have to put all of them in one matrix. Okay. And then you have to apply the row reduction method, right? You need to convert this particular matrix into the equivalent form. So maybe you can do it, and if you do it, then you will be finding that there will be one column which is a linearly dependent on other columns. Maybe I can just do a hit and trial method. Maybe if I can find out it. So what you can do, you need -8, right? You need 5. So you need 7 here. Okay, 2 times this plus 1, you're getting 7. 2 times this plus 1, you're getting 1. Okay, no. 2 times this plus 1, you're getting 5. 2 times this 10 plus you're getting 12, and this is -8. Okay, maybe we need to apply the row reduction method. So let's just quickly do it. So if you do it, then maybe you can make these as 0, and then you can actually find out. So basically, like I can do it, but currently I'm not going to do it. So if you just do it, then you will be finding out the rank. You can find out the rank. The rank of this matrix is basically, let's suppose this is a matrix A. Then rank of this matrix is coming out to be 2. So that's why the answer here is just 2. The answer here is just 2, not 3. So just pay attention that what they're asking, right? See, they have given a general vector. they form a vector in such a way that if you decompose it and then you find the rank, then you are getting the rank as 2. You're not getting rank as 3. So just be aware about these things. See, the actual question was this. So if I just tell you the actual question was this. They were asking following set, which of the following set is a basis set for these vectors. Like, you don't need to worry about the basis and all, but just see that they have given this particular thing as an option, which means 1 2 minus 1 3. This, see, 1 2 1 2 minus 1 3 2 5 4 1 5 minus 8 7 1, right? 5 minus 8 7 1. So they have given these 3 vectors as an option. But basis set is actually the minimal set using which you can represent any set. Anyway, you don't need to worry about the basis and all. But if you see that this third vector is actually linearly independent vector, that's why this is not the correct option. This was the actual question, but I have modified based on our gate version, right? We always modify based on the what gate can ask. Within the gate boundary only, we just ask the question. So most probably you might have done the mistake. If you have done the mistake, just let us know in the comments. Okay, thank you so much. Yeah. And also at Go classes, we are offering free engineering mathematics course, and we are also offering discrete mathematics as free of cost. So free engineering mathematics, free discrete mathematics. So these two courses are completely free. If there is anything that you are not able to understand in this particular video, then definitely check out the engineering mathematics course. You will get to understand everything very, very clearly. Okay. Thank you so much.